Yeah, I draw this diagram, question number 4 in the paper number 1. Okay. Yeah, that question was this way. We have a pulley like this and another pulley like this, right? And the spring. And the other end, let's see, particle carries on. Diagram we drew last week, people. Okay. Yeah, this particle has a mass m there for the weight mg. The ground is here, right? Ground is here, right? This mass is 4m, weight is 4mg. Tension along the string everywhere being the same because the string is light and inextensible, like this. Okay. And we draw this diagram at time t equals t. Right. So then I mark the distances at time t equals t. From this level, this is the fixed level. From this fixed level, we measure the distance to this place x at time t, and here to this level at time t xy is here. Then you know the acceleration x dot x double dot velocity x dot here, velocity y dot, acceleration y double dot. Okay. Yeah. Then we can write at time t, length of the string. Length of the string you can write how? Here y, right? If this is x, this is also x. This portion is a constant, this portion is a constant, this portion is a constant. There are three constants together, give single constant, people. Then I can write x plus, y plus, all the constants together give single constant c, and that is equal to L. What is L? Length of the string. Right. So then we differentiate this, differentiating with respect to time t, right? We differentiate with time t once, right? So then here we get x dot, here we get x dot, 2x dot coming, here y dot, this is 0, this is also 0. This we get a relation, okay? And now this one says y dot is equal to minus 2x dot. The minus sign says the directions of motion opposite. Okay. And the other data here we can obtain is, people, at any moment x dot is the velocity of the particle, this only this. Then the velocity of this particle m should be 2 times of that, right? This particle is q, this is p, this is q, no, right? Okay. At any moment, if the velocity of this is v, same moment velocity of this q is 2v this direction. That's what this relation says first. Okay. Differentiating again, right? With respect to time t, this will be y double dot is equal to minus 2 x double dot. What do you mean by that, people? If the acceleration of that q is p is x double dot multiply that by 2, the expression of this what q coming. So that means if we take the expression of this p downward dash f, expression of this q, we get upward to f. Understand? This is what it says. Okay. And now we can apply f equals ma, people. We can apply f equals ma, right? For this p downward, q downward to upward, right? Thereby we can take two equations and solving them, we can find the f, right? Now we can write this way. I think up to this finding accelerations, the marks I gave you, right? Now we can write f equals ma. We apply f equals ma. Number 1 for right q upward. Yeah, I took this acceleration as 2f p minus mg, p minus mg, right? T minus mg is equal to m times 2m alpha. Number 1. Secondly, for this p we can apply downward. Mg minus 2t, no? For mg minus 2t equals for m downward expression is f. These three two equations we get. By solving them, people, we found the this simple f, right? Then we get the answers how? Yeah, if coming as yes, g by 4 by solving 1 and 2. By 1 and 2, we get f g by 4. Then 2f coming as g by 2. Right, 2f means the acceleration of this q upwards direction. It is g by 2. So therefore, the particle q is moving right upward direction with acceleration g by 2. This one moving upward with acceleration g by 2. G by 2, and p descends downward with acceleration g by 4. Right. This is g by 4 acceleration. Okay, it is g by 2 acceleration upward. Now, really, people, what happens with this? Initially, the particle p is at a height given in the question at a height simple a, at height simple a above the ground. Okay, no? Right. Then I'll tell you the story here. Really happened. Okay. Very careful to understand this. This p moves downward a distance simple a. Understand? During that time interval, this q also moving upwards with height what people? Height 2 simple a. You can understand reason. Reason? People here, this moves, yeah, downward with velocity initial velocity v. Okay. Initial velocity v. And the other thing you can understand, when this moves, okay, people, now when this here this particle p moves, suppose 1 centimeter downward, this side and this side, the spring going downward 1 centimeter, 1 centimeter, 2 centimeters. Right? That 2 centimeters getting by this side. So therefore, you can see during the same time duration, once this moves downward a certain distance, during the same time interval, this moves upwards 2 times of the length this has descended. Remember that. That means once this moves downward simple a distance, this will have moved upwards 2a distance. Understood? Okay, then what happens is this, people, when this comes to the ground. This Q will have moved upward to a distance. When this comes to the ground, this will have a particular velocity. At the same moment, this Q will have the velocity 2 times velocity of that P. That we proved here. At any occasion, the velocity of this P is V. Same moment, we said what the velocity of this Q upward direction as what? 2 times V. That also we have proved here. Get this? Okay, right. So now when we sketch the VT graph, then we can sketch the VT graph like this, right? First, this one happens, people. Now, when this is moving downward, this is moving upward. Now we are going to sketch the velocity time graph. Velocity is a vector. Then, if you take the direction of motion of this Q, which is upwards, no. If the upward direction we take as positive direction, definitely the downward direction of motion of this P we have taken as negative direction. Understood? So therefore, the VT graph of P, Q, if we take above the time axis, that of P should come below the time axis. You have to understand that very carefully, because this velocity means a vector, not the speed. Here, velocity is a vector. Yeah. Now, the next thing is this. People, now, once this P comes to the ground with particular velocity, the P hits on the ground. The flow is inelastic. Inelastic means, people, after hitting with this ground, this particle P does not rebound. Right? We discuss, people, the collision lesson in applied mechanics. There we consider elastic what? Sphere and elastic what? Ground and whatever. Elastic means, people, when we drop something onto this ground, the particle is rebounding. That is because of the nature elastic. Inelastic means once something comes to the ground or hits on the ground, it does not rebound. So here also, this P hits with the ground with particular velocity, but it does not rebound. Then what happens? Once this particle P comes to the ground, it has moved distance A. Meantime, at the same moment, from this position, you will have moved height 2A. If the velocity of this P when it hits the ground is suppose V, that moment at a height 2A from this level, this Q will have the velocity 2V. Understand? Now, after this particle hitting with this what? Ground, since it does not rebound, what happens is the particle Q from here at a height 2A, it had the velocity 2V, no? It doesn't what? Stop there. Why? It has velocity. What is that? 2V, for instance, right? With that initial velocity 2V, right, the particle Q begins to move under gravity as retardation G. Why? No longer, after stopping this particle P here, no longer this particle and this particle will get the previous acceleration simple that we found. Why? In order to get that one, people, the both must move. Now this is not moving. Therefore, what happens is, after reaching this to height 2A, right, that P stops its motion, right? Then from that moment, the particle Q begins to move upward with that initial velocity, right, under gravity retarding motion G. Then that moves, right, under gravity retarding motion, and its velocity will be coming to 0. Then from there, it comes again downward, right, up to the same height 2A from this level. Understood? While it is coming down, what happens, people? Right? Suppose the height 2A is this level. From this level upwards only, this particle begins to move under gravity with retardation G. All right, going this way to the maximum height, it is coming back this way. When it comes back here, people, again what happens? The string gets taut. Suddenly, there will be a tension in the string, and then having a sudden jerk in the system. After this moment, the particle Q begins to move down. Because of that sudden jerk, the stationary particle P on the ground that also begins to move upward. Therefore, the particle P will be in contact with this ground during the time people, right? After starting the motion, this rises to height 2a. From that level, from that moment, this particle moves under gravity, under retardation, and coming to maximum height, and coming back to the same level during that time interval, the particle this is at rest on the ground. So once the particle this comes to the same level, this the spring suddenly gets impulsive tension. Then suddenly the spring will get a jerk, and because of that jerk, this particle and this particle that is on the ground begin to move. Right? Right? Yeah. Asking here, will there be impulsive force? Impulsive force creating there. Soon after getting the impulsive force only, this particle Q1, this particle P will get common velocity. Right? People, now we have in our applied math lesson impulsive force lesson. Impulsive force. In that lesson, we supposed to calculate that impulsive force and the velocities after that. Thereafter motion we calculate. Right? So after that level, we are not going to discuss this question. So therefore, now we are going to sketch the VT graph. Therefore, remember the story really happens is this comes down by a height simple A, then this comes to rest. By that moment, from the initial position, Q moves upward to A. From there, Q can't stop suddenly because it has the velocity. Because of that velocity that moves under gravity until its velocity becomes 0, then going to maximum height, it comes to the same level again here. Then what happens? Downward direction motion, the particle this passes this level, again spring gets short. Because of that impulsive tension creates in the spring, sudden jerk. Because of that jerk, this particle downward, then this particle from here upward begin to move with the same velocity. Thereafter, the question not mentioning anything. So after that moment only, ask to right draw the VT graph. Therefore, remember people, this particle P is on the ground during a time interval. What time interval? That time interval is people from this place. When it comes to the ground, Q is somewhere here, suppose. From here, this Q goes to maximum height and coming back to the same level. During that time interval only, this is on the ground at rest. Okay. Now I think you could understand everything. Now we can sketch the graph. Okay. Right. Yeah. Now we'll draw the VT graph like this. The VT graph. I'll first draw the VT graph like this, people. Try to understand this. Right. Then right. Now we can take, let me see. V axis, right? This is the right. Okay. I'm taking this upward direction as people positive direction, right? Then I can draw. It is moving upward direction with acceleration g by 2. So therefore, if I take it like this, people remember? Right? This I draw that one now. Let this angle be alpha. Remember tan alpha? Tan alpha is the acceleration of Q. It is g by 2. Right. I took the upward direction as positive. Right. So now to come to the maximum height, to come to the height 2a, the time is this. During that time interval, P goes to downward. Right? The depth simple A, right? Then I can draw it like this. So what is this VT graph? This is the VT graph of that P. Let this angle be gamma. So what is tan gamma? The acceleration of P. It is d/4. Right. Now, thereafter what happens? This particle Q moves under gravity with retardation G. Then what happens? Its velocity decreases. Then at the maximum height, velocity 0. Understand? So how to sketch that part? That part we can sketch like this, no? This way. Velocity decreasing here, retardation like this. Right? This way. Then if I take this angle as theta, it tan only gives us what? While the particle moving upward, its retardation, it is G. Then tan theta is G, right? Right? Okay. It's also correct. Now you know the same height from here to here, the height ascended under gravity by this Q should descend downward to reach the same level. That means the same area, this right below the time axis we need. And then I draw it like this. After reaching to the maximum height, the Q also coming down. Therefore, its direction also negative, right? Like this. Okay. Then this area and this area suppose become equal at this time moment. Right? Okay. Right. Yeah. Now, at this moment, time point, the particle just comes to the same level. Right? Then, after this time moment, what is this time point? This is time moment. This particle P comes to the ground. After that, it does not rebound. No, it is resting. It is resting during a particular time interval. You know that time interval is after reaching here, particle Q goes to maximum height and coming back to the same level. During that time interval, the particle P was at rest on the ground. So therefore, this is the time moment, this particle Q going to maximum height and coming back to same level, this. Up to here, from here, right, the VT graph of P. What happens, people? No velocity for P, but time is elapsing. No velocity means velocity 0 of P. It is no stationary. So therefore, during the time interval from here to here, that P is on the ground at rest. Therefore, its velocity graph should go along the time axis like this, because on the time axis only its velocity is 0. So this is the VT graph of P, and the VT graph of Q is, people, this. This is the VT graph of Q, the time axis. I think you would understand this VT graph. If this is theta, this is also theta. Right. Now we can come to the calculation part. I'll take this as O. Yeah, E. Right. And this is B. And C, D, E. Okay. You know, this point, if I take as F, OBF, OBF area gives the distance moved by this P downward, simply. During that time interval, I told you, once this P moves downward 1 centimeter during 1 second, during the same 1 second, Q moves upwards 2 centimeters. So therefore, during this time, or to be time, that P moves downward A, during the same time interval, Q moves upward 2A. So therefore, the area OAB should be what? 2A, right? OAB area, people, 2A, no? OAB area 2A. OAB area is equal to simply, right? Okay. Now, given that this way, yes, question says, Right. After a time t, particle p tracks the flow. Particle p tracks the flow means people. This is the time t. Simple. Right. Let us take this velocity as right. This velocity. If I take the velocity of this p, when the p hits on the ground, if the velocity is v, you know that moment the velocity of a should be what? 2v. That we said, velocity of q is 2 times that of p. That also we said. Right. Now we can say this way. We can write tan alpha by the VT graph. By the VT graph, you can write tan alpha. Tan alpha is what? 2v divided by t. But what is tan alpha? Tan alpha is g by 2. G by 2 equals 2v by t. Thereby we can subject v. V can be found as dt by 4. Right. OAB area, 2a we know. Now people, we can write OAB area. OAB triangle area is 2a. OAB triangle area you can write. What is that? It is half base is 60 into perpendicular height 2v equals 2a. Okay. Right now. Then here you can cancel down this 2 and 2 t times v. V is this answer gt by 4, right? Equals to a. By this people we can take the answer t 8a. T squared equals 8a by g. T squared equals 8a by g. Then what is t? Taking the root of this, we get t is equal to 2 times square root of 2a by g. Right? This way we can find the time t, right? It is one answer, I think, no? Yeah, t is this. Okay, people, now what is this capital T time? During a time interval capital T, the particle P is at rest. That's what we are given in the question, no? The time capital T, when I show in the diagram, this is that time capital T. Right? The particle P resting on the ground during a time capital T. That time is nothing but this time, no? From here to here. Okay, right. Now we need to find the next calculation. It is this. You can very clearly understand. From here, it goes to maximum height under gravity, and from there again it comes to this level. The height risen and the height descended being equal. That means this area and this area should be equal. Understand? Okay. Then we can write next thing. The area, ABC area, ABC triangle area is equal to CDE triangle area. Okay, right. You can very clearly understand there. Here we can write ABC area. ABC area you can write half BC into perpendicular height AB. CD area half BC is CD, height is DE. This half and this half you can cancel down, people. Then we get what? BC into AB is equal to CD into DE. But you know, here you can very clearly see, but tan theta ratio here you can write. What is that? AB upon BC. But AB upon BC is a tan theta here. And tan theta here you can write DE divided by CD. DE divided by CD. Right? Tan theta I wrote this divided by this divided by this. Okay? Right. That relation we need here to simplify. You can now write here by using cross multiplication. AB you can subject this is using cross multiplication. DE into BC divided by CD. This one we can put where here. Therefore, we get what? BC times AB. AB means DE into BC divided by CD is equal to CD times DE. Understood? Now, people, what happens is there, this DE, you can cancel down with this DE. Then here BC and BC together, BC squared, CD and CD, CD squared. That says people BC and CD being equal. That means BC time means this, CD time means this. These two times are equal. That you can't use directly. If you use that directly, you lose marks. We have to prove that this way. Understood? Right. So far, the marks we got. I can give you this way. For the correct diagram, people, 20 marks given. Right? 20 marks given for the correct diagram. Right? That's, yeah, 20 marks given, right? Marks given, right? And write in this way. This one 5 marks given. Okay. And OAB area, write in this 2A, 5 marks given. And the answer this one 10 marks given. Okay, right. Now taking this ABC area equals CDE area, 5 marks given. And using that, finally deciding this BC time is equal to CD. And you know, BC and CD being equal mean C is the midpoint. Therefore, BC time should be what? Capital T by 2. BC time is capital T by 2. Therefore, BC time is capital T by 2. For this, you get another 5 marks. Right? So with this 5 marks and this 5 marks, 10 marks come in, right? Deciding this BC is T by 2. Right? You can't take that directly, people. You have to prove that. They are equal, but you have to prove that. How do they become equal? Right. So now our next purpose is to find people what? This time capital T. Right. This ABC area you can write how? Opposite side divided by the adjacent side. Okay. All right. Then people, shall I erase this part? Okay. Will you complete the note? Okay, no? Yeah. Right. So now I can write like this. Shall I write that here, people? You can see the board, no? All right. By ABC triangle, we can write. By ABC triangle, we can write. By ABC triangle. By ABC triangle, we can write tan theta is equal to 2V divided by this adjacent side BC, it is capital T by 2, no? Capital T by 2. Then this 2 goes to here. All right, now substitute for tan theta people G. Right, this 2 comes to here 4. Now there we have V. The answer of V people we found dt by 4. dt by 4. And this capital T here we have. Then that gives us 4 and 4 you can cancel down. D and G you can cancel down. Then this T to this side, we get T equals simple. That means this time capital T is again equal to simple T. Okay. Simple T we found as this one. Therefore, capital T also that answer, right? Therefore, T is equal to 2 times root 2V upon G. This is how we find that T. Okay. Yeah. What's asking next? For that calculation, people, you get the marks like this. Write in tan theta, right? Write in tan theta. Here, 5 marks given. And getting this answer, given another 10 marks. 10 marks for this. For this 10 marks. Okay. Now asking, next one is what, people? Show first that the particle Q reaches a maximum height 3A above the floor. All right. People, maximum height means this. You know, from here to here. When this P comes to the ground, we told from the starting point, Q rises height 2A. This is 2A. After that, from this level, particle Q moves upwards under gravity with retardation G, another height. That height is given by people this area. No? Why? this VT graph, this portion of VT graph shows the motion of Q after this level under gravity coming up to its maximum height. That area gives this height. Then total height ascended by Q going to be people this 2A plus this part. That height from here to here, now you can find by calculating this ABC area. Understood? Right. We'll write the ABC area now like this. Right. So then I write this ABC area. ABC triangle area is half base BC. It's now we found B by 2 half base into perpendicular height 2B. Now you can substitute there. 2 and this 2 you can come down half, right? This simple T, no, capital T simple T. We get V times T there. Right. I think VT is here. You have no VT product is 2A. Then I can put here 2A. Half into 2A. Correct now, paper? By OAB triangle 2A. We wrote no C and B product is 2A. So therefore, this and this you can cancel down. Then the ABC area we get as A. ABC area we get as A. Understood? That means people from here, the height is A. Okay. Then what is total height ascended by this particle Q? It is people 3A, no? A to A, 2A, and A, 3A, right? Then you can write total height ascended by particle Q is 3A. Then you get marks like this. Getting this answer of 5 marks coming, and the ABC area right in this way, another 5 marks coming, and people finally getting the final answer 2A plus 3A, writing that in words. Therefore, the maximum height ascended by the particle Q is 3A. You get 10 marks. So then you must try that in words. You must try that in words. Write down. Therefore, maximum height ascended by what is asking there? Therefore, particle Q reaches maximum height. Particle Q reaches a maximum height 3A. That way you must write. For that you get another 10 marks. So that's how we discuss that part. Remember, people, this question you must do within maximum 15 minutes. Okay, maximum 15 minutes. A similar question was in the past paper. I can remember that paper was 2016, right? So therefore, if somebody thinks this kind of question not coming to the paper, right, give away those ideas, right? So this question, similar question was in 2016 paper. Now you can do that question, right? Do that question yourself, right? So with the help of this, I think that question very easily you can manage, right? Okay, people. Now the next question is number 5. Relative acceleration question. Relative acceleration question, right? At question of 5, given a smooth wedge cross section as shown in the figure has mass 2m. The face of it is inclined at an angle alpha to the horizontal. Upper face is horizontal. Wedge is placed on a smooth horizontal plane. Two particles P and Q of masses 3m and m respectively are joined by a light inexorable string are placed as shown in figure. Particles and string lie on the same vertical plane through the center of the wedge, and the system is released from rest with the string taut. Should the acceleration of the wedge is this much, if alpha 60, should the tension the spring is this higher. We'll draw the diagram. The mass of this is 2m, no? Then 2m is the weight. Here we have pulley. Passing all the pulley like this. right? Mass in with mg, normal reaction is starting with q here. Right. This is p, weight is 3 mg. Now there will be a normal reaction that is perpendicular to this plane now. This angle is alpha. Tension to spring is the same everywhere. Like this. Okay. By the horizontal plane, there will be another reaction like this. Okay. Right. What happens is now when the system released, the wedge is moving to rightward, and this particle P moving downward on this plane, and Q moving this way. Right now, when there is a fly standing on this pulley, it says once this move, P moves downward on this space with particular acceleration, with the same acceleration, this Q comes towards it. So that means relative to that fly, the acceleration of Q, let us take this direction as simple left, this way simple left. That simple left is the acceleration of P and Q relative to wedge. Now wedge moves to rightward this way with acceleration capital A. Then we can write acceleration of this 2m. That means the wedge relative to earth, rightward left, right? Acceleration of Q relative to earth, right? Q moves this way simple left. Meantime, the wedge takes it to right with capital F. Then in the leftward direction, if I write the acceleration of this simple m, that means people leftward F, rightward capital F I can write as minus, then F minus capital F. Okay. And this P, its acceleration is relative to earth. This direction F, rightward capital F this way. This angle is alpha. Okay. This way we can write the acceleration, right? Okay. People, in this question, because it's a very actually one question in the paper, marks given for this also. Usually we can expect if the question is actually a little bit shorter, for this also you get marks, 5 marks coming. But this time in my marking scheme, 10 marks given for each, right? 10 marks given for each. This is 10 marks, 10 marks, 10 marks, right? Sometimes in the AL paper, for this you get 5 marks, sometimes no. Okay, but there's a chance of getting the marks for this as well, because in the past marking schemes, when you go through, you can see for them also marks offered. Right. Yeah. Now we can write for the whole diagram. For the whole diagram, people, marks given, 20 marks given for the whole diagram. Right. That 20 marks you get if you have marked all the forces and acceleration on the diagram. Otherwise, you won't get marks. So therefore, people remember, when you draw a applied diagram, all possible forces, direction of motion, whatever we have to mark to get the answer. So to write the equations, you have to show. Then only you get full marks. Right. So now we write F equals ma, applying F equals ma. Number 1, we can write for P this direction. It is what, people? This 3mg, if this is alpha, the compound is 3mg sin alpha, right? 3mg sin alpha minus P coming equals 3m times its acceleration of P should be taken from here, no, people? What is that acceleration? Around this direction we apply, no? Relative to earth only we have take it. Simple left, this also alpha, capital F cos alpha minus, simple F minus capital F cos alpha. This is number 1. For this 10 marks given. Okay. Number 2. For Q left word. What is the force? T. T equals, it passes simple M. Acceleration from Earth going to be simple F minus capital F. Simple F minus capital F. Number 2. For that also 10 marks given. Next one, number 3, for whole system. Whole system. Whole system, applied right word. People, what is the external force action on the whole system? External force is 0, no force externally acting. Right now, no force, right? 0. Right? Then we get here 2m, right? 2m times capital F, right? And next one, what? Simple M, this one. Its acceleration related to Earth, we have leftward, right? But we apply this time rightward. So M time, then the rightward acceleration going to be capital F minus simple F. Capital F minus simple F. And next one, this particle P, its mass is 3m. Acceleration rightward direction. What is that? Capital F rightward, simple F cos alpha leftward. F minus simple F cos alpha. Then by these people, remember the bracket like this M you can cancel down now. Then here we have 2f, here we have f, here we have 3f. Then we get 6 times f there, no? 6f coming. And the other simple f terms, when you take together from here and here, we can take with minus sign out. Then we get 1 plus 3 cos alpha times f. Correct, no? Okay. 1 plus 3 cos alpha times f. Right. Then right. This left hand side 0. Number 10. Number 3. Right. For this also 10 marks coming. Then you have a small work. What is that? What is asking people? Asking to find the yes. Show that the acceleration of the wedge is this. And alpha equals 60. Show that the tension in the spring R. Acceleration of the wedge. Asking capital F only we have to find. Yeah. How to take the answer? I'll give the method of getting this answer. People, this is how we take the answer. Right. You must complete the rest part as homework. Right. Simplification, of course, we don't, of course, supposed to but learn by this paper class. Simplification we know. And now the simplification part you have to do and take the answer. Right. Okay. This is the way of getting the answer. First, add this 1 and 2. First, add this 1 and 2. What happens, people, there? Minus 3 plus 3 will cancel. The left hand side we get this one. Right hand side we have simple F and capital F in that equation. We need to find this capital F. Then what we do is this. By number 3, add 1 and 2. And then by number 3, subject this simple F. That will be coming in terms of capital F. Okay. Now, this simple F answer, we have to substitute. When we add this 1 and 2 to the right hand side, we get simple F. No? Taking this simple F to one place, to that simple F, substitute this answer. Then the right hand side of adding 1 and 2, we have only capital F. Then you can find this capital F. I think you could understand. Yeah. Do like that. Take this answer. Then capital F you can take. And people asking next what? The yes, tension in the spring. Tension in the spring can easily be found, people, right? You can now get the tension by substituting in the relevant equations, right? You know, capital F we know. Then putting that capital F here, get now the simple F. Then both that simple F and capital F, we can substitute where here in number 2. Then we get this P, the answer also. Right. From there, till the final answer, people, you get marks 10, 20, 30, 40, 50, 60 marks coming to the last answer. So therefore, I leave that as homework you to do. Right? I think you can simplify, right? The people, they need to improve your skills, do as homework and take this answer. You know the method now. Understand? If somebody suppose to take everything from here to copy down, people, no point of doing the paper class, right? So in the paper class, usually, right, we give the method to get the answer. The rest part, of course, you should be able to do simplification part, especially simplification part, right? So now when we do a question in the theory class, usually I simplify everything by explaining well, step by step. So that right ability now you have to use here to take this answer, right? That's all in that question, right? Okay, now we'll move to people question number 6, right? Question number 6, of course, another good question, right? Some of the students, they said this, not some, almost all students, they said the paper is difficult. Really, not difficult, people. Some questions are there. That's all, huh? Yeah. Now we'll come to the question number 6. Question number 6, right? Right. Right. It is this. A smooth hemispherical ball of radius simple r rests on a smooth horizontal table. A uniform rod of length 12 and of weight equal to that of the ball rests partly inside the ball. At the position of equilibrium, the base of the hemisphere makes an angle alpha with the horizontal. The part of the rod inside the ball subtends an angle 2 beta at the center of the ball. Show that L sine alpha plus beta, this answer. So first that the reaction R on the rod at the rim of the ball R is this, huh? We'll see. Yeah, so this is a good question, really. Right. Here, this way we have I draw the diagram. Right. Yes. These are alternate plane. Right. And if we produce this way, the clear diagram is very important, people. This question depends on your correct diagram. Right. This line is the base of the ball. Huh? We are given that makes an angle alpha. You see. This is the, I'm drawing the radius which is perpendicular to this base. Huh? This radius is perpendicular base. On this radius only, the center of gravity of the hemisphere available. Where's the center of gravity of a hemisphere, people? It is at the midpoint of this radius, which is this radius is perpendicular to this base. Huh? Midpoint on that. Yeah. Now the rod is resting like this. I'm going to draw down the rod. Right. The rod is resting this way, people. This is the rod. This is the rod. People, now usually the questions we did in our classes, in those questions, remember this hemisphere was fixed. It was fixed to a horizontal plane like this, so that this hemisphere can't move. That occasion, when we keep the rod, we can keep the rod like this because this hemisphere can't move. But in this case, people, the hemisphere is placed really on the horizontal plane like this, and the rod is placed. Then, since this hemisphere has the freedom to move, it will tilt to a position like this. That is important of this question. Right. Okay, let's see. Right. Now the center of gravity of the hemisphere is at the midpoint of this radius. If the radius given as r, no, then this is r by 2. This length is r by 2. The weight is w. Given now, weight w acts this way. Weight is w. Weight w. Right. People, by this horizontal plane, there will be a normal reaction acting on this ball. That is going through this point because that should pass through the center of the ball. Okay. So let this reaction be P, here 90. Okay. Yeah. Next one is by this contact, by the ball to the end of the rod, there will be a reaction. That reaction should pass through the center of the ball. Therefore, I first draw like this a line, right? Along this line only, the reaction acts now. Draw the line. You have to draw the line. This way. The reaction supposes that passes through the center, and that line only I am producing this way now. Right? Okay. Okay. Now at this point, people, this point is the rim on the ball. By the rim to this rod, there will be a what? Normal reaction. We learned that in Koppen force of system. Go to that note. That reaction is perpendicular to this rod. Therefore, its line of action should pass to the point. It's understood, right? Let's see, we can mark that. Here are 90. Okay. Now, people, what are the forces so far acting on the rod? These are and this says, what is the next force acting on the rod? Its own weight. Altogether, with this weight, number of forces acting on the rod is 3 people. We know, we learned in common forces lesson, when any object is in equilibrium under the action of 3 forces, they must meet in a point. Or if 2 of them are parallel, the third one is also parallel to them. That way, one theorem we have learned. So here, the third force, that is the weight of the rod. Since the other 2 forces R and S meet pair here, the weight should be passing to the point this. So therefore, the easiest way of marking that is, right? The easiest way of marking that is, people, from this point draw vertical line. That vertical line meets its rod. That is the center of gravity of what? The rod. This is the weight W of the rod. Okay. This is the force diagram. These are now we are given next one like this. For that, it is this rod of length 2L. That's okay. The length from here to here, here to here, 2L, right? Radius of the ball is R. That means, people, from here to here, it's R. From here to here, also R. Yeah. And next one given this way, the part of the rod inside the ball. Part of the rod inside the ball means this, people. This is the part inside the rod. This from here to here, the portion. That is the portion inside the ball of the rod available. That subtends an angle 2 beta at the center. That means, people, this point and this point, when we join to the center by 2 lines, between that 2 lines, the angle is 2 beta. That is it. This angle only, people, given as 2 beta. This is 2 beta. This is 2 beta. Okay. And you know, this is a radius, this is also radius. Therefore, this angle here should be equal to this angle here. Right? We know in a isosceles triangle, the angles which are opposite to equal sides are also equal in sizes. Therefore, this angle and this angle equal. But here 2 beta. The sum of these 3 angles is 180. Then sum of this angle and this angle, but 180 minus 2 beta. Since they are equal, each angle, this and this, should be equal to what? 180 minus 2 beta divided by 2. What is that? 90 minus beta. Is it clear? Right? 90 minus beta, right? So this is now 90 minus beta. 90 minus beta. It's also 90 minus beta. Okay. Now we are given next one this way. Right. Yeah, people, now I can this way going. This point when we going like this. Right. If I draw a horizontal line, to this point, if you draw a horizontal line to that point, that horizontal line will meet the what? Ball here and come in this way. Right? When you draw this correctly, people, the horizontal line going through this point will pass through this point and meet here. Okay. Right. Now I'm going to take this angle as theta, people. I'm going to take this angle as theta. I'm going to find that angle. On this angle, I'm going to take as theta. right? This is horizontal, and this is also horizontal. These two are horizontal. Therefore, this angle and this angle being equal alpha. Okay. Then you can write. Then you can write. This way, people, you can write this theta and this alpha should be equal to this angle. Correct, no? Correct, no? So there you know one theorem you learned in oil. This way we have a triangle. The sum of the two interior opposite angles, this plus this, should be equal to the exterior angle. So like that here, this alpha and this theta, when you add, that should be equal to this exterior angle 90 minus theta, right? So then we can start the calculation part like this. By the diagram, you can write theta plus alpha is equal to 90 minus beta. Then theta you can take this alpha to right hand side, 90 minus within bracket alpha plus beta. Correct, no? When you take this alpha right hand side, minus alpha coming, take minus sign now, within bracket alpha plus beta coming now. Then this theta angle is okay. Theta is what? 90 minus alpha plus beta, right? 90 minus alpha plus beta. Okay, right. Okay, now I'm going to find this angle also, people, the whole angle. This angle, whole angle I'm writing now. That angle is what? 90 minus beta plus this. Okay, what is this whole angle? This whole angle is 90 minus beta plus this small angle, this 90 minus L plus beta. When you simplify this, you can see, people, 90, 90, 180. 90, 90, 180. Right. Here we have minus sign. Here we have minus sign. When you take minus sign out, within bracket you get what? Alpha plus beta, L plus 2 beta, right? This angle also we need to take this answer. Okay. Then here, people, for the correct diagram, 50 marks given, but at the examination you get nearly 20 marks, so 15 marks, because this question come in with another question. For the whole question, 150 marks come in. Then that 150 we have divided into two, not equally, according to sizes of the questions, proportionally divide. Then for the other workings also, the marks should be given. So therefore, not this much 50 you get, but in this case, to offer 150 marks, one question, no, 150 marks, to offer 150 marks, less steps. So therefore, 50 marks is offered for the diagram. That 50 marks you can earn if you have marked all the important things which we need to take the final answer. So those things, of course, included the correct diagram with marked forces, and this angles you have found. For them, the altogether 50 marks given. But for the angles, of course, in this marking, another 20 marks given in addition to this diagram 50. So therefore, the 10 marks, 20 marks given for the angles. This, yeah, finding theta for this 10 marks given, and people, for this one also 10 marks given. Right. Right. Now, first answer is obtained like this. I'll take this length. This point, suppose A. This point is B. Right? Yeah. This AB length, you can write in, people, two ways. AB length. AB length you can write. Here 90, no? Here 90. Reason? This total line is horizontal. This total line is vertical. Therefore, they meet at 90-degree angle. Right. Now, this AB length you can write. AB length you can write this way. From here to here. R, R2R. This whole angle just now we found. What is that? 180 minus L plus beta. Therefore, we can write AB length like this. AB length you can write people like this. AB length you can write 2R cos, no, the length from here to here, 2R cos this angle. What is this angle? This angle is what? 180 minus L plus 2 beta. 180 minus L plus 2 beta. Then we can write AB cos 180 minus something. What is people cos 180 minus theta? Minus cos theta. Like that. Here we get cos 180 minus this angle means minus cos this angle. Minus 2R cos L plus 2 beta comes. Okay. Next one, I can write the same length AB. Same length AB, I can write. People now, the whole length of the rod from here to here, half of that, no. The whole length of the rod given as 2L. That means from here to here, 2L. Then from here to here, it's L. L times the small angle, theta. Then from here to here, L, this is theta. L cos theta means again AB. Also, you can write AB, you can write as what? L cos theta. But what is cos theta? What is theta? Theta is 90 minus L plus beta, right? 90 minus L plus beta. 90 minus L plus beta. You know, cos 90 minus L plus beta means, you know, cos 90 minus theta is what, people? Cos 90 minus theta is sin theta, no? So therefore, we get L sin L plus beta here, no? L sin L plus beta, right? So then same AB here and here. Therefore, this right hand side must be equal. Then you can write, therefore, what? L sin alpha plus beta is equal to minus 2R cos L plus 2 beta. Right? Yeah. We'll take this as the first relation, number 1. Right? Then marks given here by the diagram. Right. For this one, 10 marks given. For this one, 10 marks given. Okay. And getting the first relation, this one 5 marks given. Okay. Right. Now, to take the next one, I take this point as C. Right. A similar question I did in my theory class, but the physical student I was unable to do that. But with this online students I did that. But I can remember for the theory students I put that recording. This kind of question I discussed. Okay, right. Now what I'm going to do next is this. For the equilibrium of the system means this ball plus this rod both together, the system. Rod and the ball together is a system. When we consider the system, people, you know, internal forces get cancelled. Now here I have marked only this R. This R is acting on the rod by the hemisphere. The meantime, another R coming toward this what? Hemisphere by the rod that is not marked here. They will cancel off when we consider the rod and hemisphere together. When we consider that R equal opposite will cancel. Here also the same is coming on the ball. S and S equal opposite will cancel off. Then for the whole system, when you take moment around C, the forces which give moment, people, only 2 forces. What are the forces? The weight of the hemisphere and the weight of the rod. They are the forces which contribute the moment equation. Then write down like this. For the equilibrium of the system, taking moments around C. Take in moments around C. Take in moments around C. Yeah. You know, people, here, the length from here to here, R by 2. R by 2. Okay. Now, this angle, if I find people, this angle, people, how to find this angle? That angle we can very easily find. You know, this angle is alpha. Here 90. Here 90. Then this is 90 minus alpha. But this angle and this angle 90. Therefore, this is alpha. Am I correct? Here alpha, here 90. Therefore, this is 90 minus alpha. This and this 90. Therefore, this is alpha. Now, when you take moment around C, by the W weight of the hemisphere, the required perpendicular distance going to be, people, this length. Around C, when you take moment, people, you can very clearly see the perpendicular distance to this W is this length. But this length is equal to the length here, this length. Right? When I draw horizontal line, this is the horizontal line here. This is 90. Therefore, this length going to be what? R by 2 is this length. This is alpha. Opposite side we need. Therefore, it is R by 2 sin alpha. R by 2 sin alpha. Now, the weight of the rod. When you take moment around, see, the weight of the rod gives moment. The required length is this. How to find that? That can easily be found like this, people. When I draw horizontal line here, when we draw horizontal line here, okay, this is then required length, this and this being equal. This angle, people, equal to this whole angle, no? Why? This is horizontal, this is also horizontal. This is the transverse line. Therefore, this angle and this angle being equal because of corresponding angles. Then this length from here to here will be equal to what? R times cos of this angle. That angle is here, we found 180 minus L plus beta, L plus 2 beta, right? So then we can write the moment like this. I first take the moment by this W times people, what? R cos what? This angle. That angle is equal to this 180 minus L plus 2 beta. 180 minus L plus 2 beta. Okay, that should be equal to what? Moment made by the weight of the hemisphere. It is W here. This length I told you R by 2 sin alpha. W into R by 2 sin alpha. Yeah, you can see here. Cos 180 minus, it means minus, no? Minus cos L plus 2 beta. Minus this W and this W can cancel down. We can bring this 2 to this side. 2R cos L plus 2 beta. Correct, no? Cos 180 minus something means minus cos that angle. This is beta. And this R and this we multiply. Then right hand side we have R sin L. Right. This is number 2. Now you can see something in number 1 and number 2, people. What can I say? In number 1, minus 2R cos L plus 2 beta. Number 2 also that is available. Then this equals this. This one equals this. Therefore, what can I say? This equals this. Thereby, you get the first answer. Understood? That is what asking to show people. Then you can write by 1 and 2. Hence, by 1 and 2. Now you get this answer. Right? What is the answer? L sin alpha plus beta is equal to R sin alpha. Correct now, people? Huh? This equals this, right? Same thing equals this. That is why we say L sin alpha plus beta is equal to R sin alpha. Both are now equal to minus 2R cos alpha plus 2 beta. We say we can write that first answer, right? Now, the marks come in. For the moment equations, people, we get 10 marks. Okay, moment equation, we get 10 marks. And simplifying and getting this second equation, another 5 marks come in. Okay. And equating by 1 and 2, getting the last answer this way, other 10 marks. This is really a good question, people. Huh? Really good question. This question, or this kind of question, this question I took from a book, Indian book, Indian, I think, Indian examination book, examination question, right? Examination question. And the similar question was in the year 1994. AL, we have applied what examination? A similar question was 1994 AL. Huh? Yeah. Now, next one asking the normal reaction. No. Next one asking what? Show first that the reaction R on the rod at the rim of the ball is this. That means this R asking, right? R. This R. Even how to find this R? R can be obtained only for the equilibrium of the rod. Only for the equilibrium of the rod. We consider the equilibrium of the rod. Considering the equilibrium of the rod, we take moment around A. We take moment around A. People, now when we consider only the rod, what are the forces acting on the rod? This R acts on the rod. Okay. Its weight acts on the rod. And this S acts on the rod. When you take moment around A, this S won't give any moment. Right? When you take moment around A, S won't give any moment. This R gives this way anti-clockwise moment, W gives clockwise moment. The rod is in equilibrium, therefore their two moments should be equal. Understood? Right? Then we can write down for the equilibrium of the rod, taking moments around A. Taking moments around A. Right. When you take moment around A, what do you get there? R times R gives this way clockwise moment. R times. What is the perpendicular distance to this line of action of R from A? It is this length, people. This length. What is that? R, 2R. This is 90. And this angle. What is that? Towards the angle. 2R cos 90 minus beta. 2R cos 90 minus beta. Equals weight W times the length from here to here. L. This length only we need to take the moment of this W around A. This length I can take. This angle is theta. Theta is this much. Then what is that? L cos theta. W into L cos theta. Right. But theta is, people, what? 90 minus L plus beta. 90 minus L plus beta. Put that there. R 2R cos 90 minus beta is sin beta. Equal W times L cos theta. This theta is, people, 90 minus L plus beta. No? L cos 90 minus alpha plus beta. Like that. Now here we get what? WL cos 90 minus L plus beta means sin L plus beta. Here R into 2R sin beta. Okay. Then you can subject R. For the sin L plus beta, if necessary, you can substitute people. Sin L plus beta here. R upon L. We can subject sin L plus beta here, no? L sin L plus beta here for the whole part. L sin L plus beta. By the previous answer, we can put R sin alpha. Then we get this answer for R. For the moment equation, this one, 10 marks given. And now you can write the same thing like this. R into 2R sin beta equal W times L sin L plus beta. L sin L plus beta, it is this, no, it is equal to R sin alpha. Put that there. Then this R and this R we can cancel down. Capital R can be subjected. These 2 sin beta we take to right hand side denominator. W sin alpha is on the right hand side. Bring this 2 we are here. Here we get 2. Sin beta comes to the right hand side as 1 upon sin beta. Then 1 upon sin beta means what? Cosec beta. So then we can write this capital R. Therefore, capital R is equal to W by 2 sin alpha into 1 upon sin beta means cosec beta. 1 upon sin beta means cosec beta. Right? Then we get another 10 marks for this answer. Substituting for this, L sin this L sin alpha plus beta, it is this one, no? What R sin alpha, this one, other 10 marks. So this is how people we take a answer. This is how we take a answer.